I'm Sara Jackson. Thank you for coming to my talk, Chaos Engineering on the Death Star. This talk covers a topic that may require some prerequisite knowledge, so let's get some things straight. The Galactic Empire is bad. The Rebel Alliance is good. And the first Death Star was destroyed as a result of poor planning, poor execution, and hubris. Hubris to assume that nothing would go wrong and everything would go according to plan. The internet sees hubris and laughs. Things will go wrong, and we should prepare for it. Chaos engineering is a tool we can use to prepare for the unexpected. It can help prevent incidents, improve user experience, and increase team confidence. And so much more. So what is chaos engineering? Chaos engineering itself is a bit of a misnomer. If you've heard of Netflix's tool Chaos Monkey, you might imagine a monkey wildly disrupting the system, shooting off blasters with the aim of a stormtrooper. However, chaos engineering is a technique more similar to the scientific method. It's strategic and planned. So let's see how each of the steps of the scientific method play out in chaos engineering. Observability is key. We need to know how the system acts normally to compare how it responds under an experiment. So step 0 should be ensuring you have sufficient observability in the area of the application you'd like to test. We'll then form a hypothesis to base our experiment on. Like, my application can withstand a few servers going offline, or my application will fail gracefully from an unexpected HTTP response. Experimental failures can then be injected into a production environment, the outcomes of which will help prove or disprove our thesis. By analyzing the logs and metrics recorded during the experiment and comparing them with a baseline, we can learn exactly how our system will react in the scenario. If our hypothesis was false and the system was degraded or taken offline when a few servers are also offline, then we can make a plan to implement improvements to our system's resiliency. This is a proactive approach to fault tolerance. Now, chaos engineering is traditionally within the domain of infrastructure and DevOps, and this is a Ruby talk. There is a growing interest in running chaos engineering experiments at the application layer. Focusing on the Ruby application tightens the feedback loop for us developers and lets us think about improvements we can make for our users when infrastructure is not working. Things like servers being unavailable and corrupt HTTP responses still result in application layer errors. So if we're injecting bad input or responses, isn't that just testing with extra steps? Close, but not quite. You see, a key difference is that the experiments run on production. Yes, that's right, folks, we're doing it live. Even the best pre-production environment doesn't replicate reality perfectly. I've seen many clients in the past wish for a way to test against the chaos that occurs in production, usually with a focus on user-provided data. User-provided data can be a minefield of the unexpected. Also, your infrastructure scale will be different. Think the number of servers, workers, threads, dynos, shards, replicas, etc. Third-party service availability is going to be different. Your genuine interactions are going to look different. The roles and permissions in your production environment tend to be more secure. And I don't know about you, but user traffic patterns on my staging environment are very different from production. The benefit of using production is having a true picture of what our user sees as a result of our experiments. So, a disclaimer. This talk is designed as an introduction. and I avoided real experiment implementation because, unsurprisingly, chaos engineering can cause real damage. It should not be undertaken carelessly, and it's perfectly fine to start your journey with a pre-production environment, especially depending on your application's risk tolerance. That said, there is so much value in being able to compare the steady-state real-world metrics to the metrics of the production environment under an experiment. Tests alone will tell you that X will happen when Y, but these experiments could tell you that X happens regularly in the steady state. An increase or decrease during an experiment will give you so much more information. Additionally, a test suite must be thorough and well-designed on its own to provide the highest level of confidence. But the world in which every application is backed by a thorough, well-tested environment suite might be in a galaxy far, far away. Meet Maia, a web developer managing the Death Star's public relations site. It doesn't have a thorough and well-designed test suite backing it, yet it's surprisingly complex, with access to live streams of target planets. She's not familiar with chaos engineering, and she's woefully unprepared for what the rebels have planned for her site. She overhears one of her fellow minions of the Empire complaining about how they can't upload a video they just took of a planet. I keep hitting upload and nothing happens. When looking into the logs, Maia sees the app is receiving 503s and failing silently. Hopefully Darth Vader doesn't try this feature anytime soon. Then a news bulletin reports that the rebels have taken over and shut down the Empire's favorite cloud service. Enter your most disliked cloud service here. No matter what your cloud service provider, at the end of the day, it's just a collection of computers. Failures happen. AWS goes down. Chaos Monkey, I mentioned earlier, is a chaos engineering tool to simulate server outages and was developed at Netflix shortly after they migrated to AWS to shore up against this very situation. They realized the best defense is a good offense. You should fail while you're watching. We can run a chaos engineering experiment to simulate this at the application layer. After all, what does a cloud outage look like to the application? A request timeout response? Or a service unavailable response? How does your application deal with these? Which of your services are affected? What does your user see? Are your logs working properly? Are you sure? When was the last time you checked? Possible outcomes of such an experiment could be that the site handled the situation well, confidence is gained for the team and management, or more realistically, our service was degraded slightly. We can now decide how we want to handle that. Shorter timeouts, for example. Or worst case scenario, our service is shut down completely. And this requires an improvement and soon. Even a page displaying a temporarily offline message would be better. So consider adding a failover service. Of course, solutions will be different depending on your application, scale, and priorities. Maia's temporary solution is to add a banner on the page indicating the upload service is currently unavailable. Although she wonders if anything else is happening on the Death Star's PR page. She clicks and clicks. Suddenly things are not as responsive as they should be. The pages are loading so slowly. And then all she sees is a white screen. A glance at her Datadog dashboard, #notsponsored, tells her traffic has spiked. And what's this? All the IP addresses are originating on Hoth. It must be the rebels. High latency can be an issue caused by a number of things. In this case, increased traffic slowing down the site. Even if an application isn't a target for a DDoS attack like this, that doesn't mean it's safe from the friendly internet hug of death. That's when a site is shared to social media and goes viral. Suddenly, the entire internet seems to be on the site and takes it down like a T-47's tow cable taking down an AT-AT. The concept of a slowdown goes hand in hand with real-world user experiences and business metrics. How long is it acceptable for your user to handle a degraded response time with no further information? When will that user decide to just leave the site entirely and spread the word? This has real costs associated with it. I know you all know. At the application layer, a slowdown can look the same as a simple sleep command. We can design a chaos engineering experiment to test the user's experience during a high latency situation. This can serve as various opportunities for improvements, like adding or improving site messaging. A shorter timeout and a message that says, hey, we're still loading, is really important for your users to know that it's not them or their internet. The site is still thinking. You could also add a loading icon or progress bar, or hey, consider adding turbo to the app's front end to lazily load some frames while things are going on in the background. So I mentioned earlier, solutions will be different depending on your situation. Fortunately for Maia, the increased traffic all originated on Hoth, so she alerted Darth Vader, and it was dealt with. Fighting the rebels is expensive. So Maia added a subscription service a while ago to the Death Star site, promising live streams of planet demolitions. Heck yeah, we love an explosion. She checks in on the site's subscriptions page, the payments for which are handled by a third-party integration. While this page should be displaying information about the recent subscriptions, but suddenly it doesn't have any values. Another check of the logs, and she sees 401 responses coming from the API. It turns out a member of the rebellion works for the third-party service and deleted the Death Star's API token. Third-party APIs are a pain to integrate to begin with. Tokens can expire on their own or be maliciously deleted by rebel scum. APIs can change unexpectedly, and these services can experience their own outages. I believe that applications should take ownership of the entire user experience on their site, regardless of third-party integrations. So we can run a chaos engineering experiment that mimics this situation by serving different error responses to the application. Existing observability can help you determine the most common one your site faces and design experiments around that. How does your site handle these HTTP responses? Is it graceful? Is your logging correct? Or, my worst nightmare, the user sees a stack trace. This is real on the US Department of Transportation's website. Retry mechanisms, graceful error messaging, and fallback options are all things that could be added to your site to improve your user's experience in these situations. Maia is at her wit's end, handling all these incidences only as they arise. If she had known about chaos engineering, she could have run some experiments and shored up the resiliency of the Death Star site. But it's the Empire, so money's tight. There's so many different areas that could experience failure. Even if she had the budget, where could she have started? Where can you start? As I said, step 0 should be increasing observability. From there, you should start small. You want to limit the unknowns when you're running an experiment. Most chaos engineer experts will tell you that you should start your experiments in an area that you are already very confident in. From there, you want to identify an area in your application that is going to limit the side effects, like a single microservice. And then you can prioritize experiments and improvements based on your own service level agreements and priorities. And remember, knowledge is power. So how do I get my team to care? You're all here listening to the whys, they're not. Well, experiments and their outcomes can provide a lot of value to the developers on your team. Chaos engineering can help build a higher level of confidence for everyone. We all want to be able to trust the code we write, and these experiments can test our theories around the unexpected. And then there's data. Who doesn't love data? Wrong talk, sorry. So this data can help when trying to lobby for tech investment. It's easier for a director to agree to choosing a tech investment sprint over feature work when you can point at the experiment's data and the costly user impact should these improvements not be made. Plus, it's cool to call yourself an agent of chaos. Well, how do I get my manager, director, CTO on board? Well, this doesn't have to be an all-in sell, and it shouldn't be. As I've mentioned, chaos engineering is best practiced carefully and incrementally. Like getting buy-in for anything, it's important to bring aspects that align with the priorities and values of your audience. So when you're speaking with a business leader, you can share details about how this practice will provide a better customer experience and increase your site's reputation. It will result in less downtime, thus fewer lost customer interactions, click-throughs, or sales. For engineering leaders, you can take a different tack and bring up how this can improve the resiliency of your app. And it can reduce the stress around launches or busy seasons. This can improve the team's confidence in the system and the work that they're doing, and improve nearly every aspect of managing tech investment, from determining areas to work on, prioritizing timing, and having data-backed evidence to get upper management on board. For the Galactic Empire, some selling points could be thermal exhaust ports are shored up, schematics are stored more securely, and the site does not go down ever. I encourage you to seek tools and methods of experimentation that will allow you and your team to see the benefits of application layer chaos engineering. Improving your application's resilience, your user's experience, and your team's confidence are worth the experiment. Here are some tools to get you started. FluShot is a chaos testing tool for Ruby applications. It can inject unusual and unexpected behaviors into your system, like we've been talking about. It can add extra latency to your network requests. It can simulate infinite loops, and it can raise exceptions. Chaos RB is another chaos testing tool for Ruby applications. It supports simulating issues like increased CPU usage, raised exceptions, long I/O wait, and increased memory usage. Chaos Orca is an original chaos engineering system for Docker. It provides monitoring and injections that are done exclusively from an app's Docker host, so it's language agnostic. If you're interested in contributing to open source like I am, I'll be at Hack Day tomorrow representing Clearance. I know some of these projects are looking for community contributions, so please consider them. Had the first Death Star properly employed chaos engineering practices, it could have been saved from such a thorough and obvious demise. But try telling the Emperor he's not doing development right. This is the real-life Maia, my 4-year-old Manx kitty. I was delighted to hire Brian, an illustrator from Fiverr, to draw Maia as the imperial officer I imagined her as for this presentation. This slide is hard to read, but these are my sources, and I'll be sharing these and other resources to get started in Slack later. Thank you so much. You can find me on Mastodon as csara@thoughtbot.social and csara@vmst.io. I won't be taking questions now, but if you find me later, you can talk my ear off about chaos engineering because I have so much I could talk about.